But speed is not everything in Wi-Fi, because as you saw, speed is important, but we're also wasting a lot of time exchanging frames just to understand the environment and making sure that things are working fine. So there is a big part of the 802.11 standard which is about trying to make the cell more efficient, not faster, more efficient, make better usage of the time we have sending and receiving frames. And there are a few amendments that you want to be aware of for the CCNA wireless and also for your work as a Wi-Fi engineer. One of them is 802.11r. This one is for roaming. When you roam from one access point to the other, you're going to lose connectivity to one AP, you're going to have to discover the next access point, and then you have to associate to that next access point. And this is going to take some time. So what 802.11r tries to do is to save on that reassociation time, that negotiation with the next access point. This is important when you have a real-time application like voice. You are on an access point and you have to move to another access point. If you have to go away from the main channel for too long, then you may be dropping some voice packets, and that's something you may hear. So for real-time applications and you have to roam between access points, it's very important that you are able to do it fast without interrupting the communication, or at least do it as few microseconds as you can. So what 11R does, it's allowing the station to still be associated to the first station on the left, and then pre-discover the access point on the right, pre-negotiate with that access point on the right credentials like security, pre-shared key, etc., and also QoS level. And once this is set, only then leave the old access points and jump to the next one. Whereas in theory for 802.11, you first have to jump off the first access point in order to jump to the next one. With 11R, you can pre-negotiate your parameters before doing so. And that's, of course, saving you time. You do it before you really have to jump away. Another one you may have heard of is 802.11u. So what this does, it's implementing in 802.11 a Wi-Fi Alliance certification called Hotspot 2.0, which aims at improving the efficiency of you connecting to a hotspot network. And what 11u does for that Hotspot 2.0 initiative is to describe how your station can discover what is behind the access point. It can say, do you have any internet connection? Do you have free Wi-Fi? Or is it a private network where I have security? You can pre-discover what is behind the access point, what kind of network is behind it, to decide if you can or not join that network. And if you can, it can also try to relay your traffic from the access point to maybe some place like your service provider, where you can pre-authenticate using maybe your SIM card in your phone, so that your station can join automatically and securely the Wi-Fi network without you having to go to a web page, enter some questions about your name and email address, etc. So in other words, 11u tries to describe exchanges of frames that allow you to discover the network behind the access point and automate your authentication to the network if what is behind allows it. So that's very efficient, because instead of using open like you would use for web authentication type of hotspot, you can do all that with a secure exchange using WPA-v2. So you automatically connect to the network without the risk of having to send frames in the clear. Not all stations, not all networks support 802.11u, but it's a good protocol and it's very promising. And a lot of service providers are implementing that Hotspot 2.0 initiative, which part includes 802.11u. Another protocol you have to be aware of, and we'll talk about it in Module 4, is 802.11w, which is security of management frames. And the reason why is because if you look at what we've been doing so far, there are some frames that are unicast and those can be encrypted. But the management frames, such as disassociation, reauthentication, beacons, etc., those are not encrypted. They are broadcast, and they are management frames anyway that you may need to send some stations to where they are not associated to you yet. So those are not protected. And that allows any hacker to spoof, imitate those frames, and disconnect clients by pretending to be the access point and deconnecting clients. So that's a problem in secure conscious environment. So what 802.11w does is to provide the ability to sign those management frames between the station and the access point, so that if anybody tries to imitate the access point, the station will know that the message is not signed properly, because there is a security code that is secret between the AP and the client, and that would be missing from what the hacker is trying to send, and therefore it's going to ignore those frames from that hacker. Again, we'll come back on that more in detail in Module 4. Another important protocol is 802.11k. What this one does is to manage the station better by avoiding them from the need to scan whenever they need to roam. And the way it works is that when you have an access point and the station joins that access point, it can right from the beginning say, what kind of neighboring access points do you see and what channels are they on? And the AP can return that list of neighboring access points. And the advantage, of course, is that the client already knows what channels to scan if it needs to move away from that access point, so it's not going to waste any time scanning channels where there is no neighbor. It's going to save time when roaming. Be careful because things are a bit more complicated than they look, as you can see on this slide. With 11K, what you do is that when you join the cell for the first time, you're going to ask for that list of possible neighbors around. So that's what we just saw. But there is also another protocol which is called 802.11v, which is a 400-page amendment to 802.11 that improves clients' conditions with many, many things. And one of the parameters is what they call the BSS transition management. And it does things that are close to 11K but are slightly different. With 11V, you will not only ask this question, what about your neighbors, when you join the cell, but that's a question you would ask when you get to the edge of the cell. So you move away from the AP, and at some point you tell the AP, I'm at the edge of the cell, I think, which neighbor do you think I should go to? And the AP can return a list of neighbors or just one if it knows where you are. So you see that's different from K, where we get that list when we just join the cell. Also in 11V, there is also the possibility where your access point can tell the client when it's at the edge of the cell, you know, your data rate is too low, you are away from me, you should not stay there, you should jump, and this is the access point you can go to. So you can push the client to another access point. That's called the unsolicited optimized roaming request. Those features are implemented on Cisco controllers, by the way. The 11V amendment also implements another ID, but no client vendor implements it yet. So on Cisco code that you have for a CCNA wireless, this is not implemented yet either, which is the one you see at the bottom, which is the unsolicited request, where the client wants to join the cell and the AP says, no, you know what, my load level is too high, I don't have space for you, join the other access point instead. So no client vendors today implement that feature because they don't want to be refused to join to any cell, so they don't implement that yet. So in code 8.0, which is the code you have to work on for the CCNA wireless, that feature is not there. 11V BSS transition management, by the way, is also not in code 8.0, it's code 8.1. The two features you see at the top are in code 8.1. So for the CCNA exam, you may be asked about 11V in general, but you cannot be tested on the feature itself because in 8.0, 11K is present in the controller, but 11V is implemented in 8.1 only. So those are the main ones. But if you're interested in 802.11, it's a good read, 4,000 pages, full of amendments. And those amendments are new ideas, as you can tell, that the 802.11 committee is working on and that get integrated into the standard. And to identify them from the original standard, we give them those letters. But there are plenty of those. So 11AC, of course, you know that one. There's also 802.11p, which is car-to-car communication, some protocol to exchange information about traffic and maybe car conditions. But also 11Z, which is direct communication between devices in a secure manner, which is a kind of extension to Wi-Fi Direct. There's also 802.11y that was published in 2008, which allows Wi-Fi in the 3.6 GHz band. But it's only for the US, and not a lot of people have been implementing it, so you may not see that very often. There's also 802.11s that we mentioned earlier on mesh networks, describing the protocol for mesh outside. And again, we say this one is not used so much yet. And many others, like 11AA on video streams, 11AD for high throughput in 60 GHz, etc. So some of them are used as they are. Some of them are taken and sprinkled in some Wi-Fi Alliance certifications about different topics. Some of them are there available in case we need them one day, but not used yet. So you see, it's a wide world. In any case, the IEEE tries to bring as many features as it can into Wi-Fi so that the Wi-Fi Alliance has as many features as needed to implement Wi-Fi in any possible conditions.